Thank you everyone for joining in. Welcome to another webinar by OpsVerse. My name is Tero, Vice President of Sales and Marketing at OpsVerse, and I'll be your host today. Today's topic is Cost Conscious Observability 101. In this webinar, we're going to explore how to save on your observability costs without compromising on performance. I'm joined in by Navin Pai, founding engineer at OpsVerse. He'll be taking us through the rest of the presentation today. Before we get started and run through the presentation, I want to review a few housekeeping items with everyone. This webinar is being recorded and we'll be sharing the recording with you all. We'll be answering all your questions live at the end of the presentation. We'll reserve 10 minutes for Q&A, but please feel free to send them over as they come up and we'll do our best to get them answered at the end. All right, without any further ado, let me flip this over to Navin to share with us some of the best practices on how to smartly optimize your observability costs and make sure that you spend on the signals and not on the noise. Yeah, Navin, all yours.
Thanks, Tero. First of all, thanks everyone for joining on this Thursday morning, Thursday night, depending on where you are in the world. Like Tero mentioned, I'm Navin. I'm a founding engineer at OpsVerse. Very quick introduction to myself. For the first half of my career, I worked as an engineer, building out high-performance systems. And then in the later half, I've been working on the DevOps side of things. So a lot of the things that we'll be talking about today will touch on both the developer aspects as well as DevOps/SRE aspect of running an observability platform that actually works for your users and for your engineers. So that's kind of going to be the focus of what we'll be talking about today. A very, very quick 1-minute introduction of what we do at OpsVerse for anyone who's new or not heard about us before. So at OpsVerse, what we do is we build out DevOps, open source based DevOps tool stacks for common DevOps workflows. So a simple way of explaining it is we basically take open source tools and kind of bring them together and package them together in a way that creates platforms, right? So we look at ourselves as being the gap between tools and what a platform is, and then we offer them as fully managed solutions, right? So we do have 4 offerings that we have today. The first one is Observe Now, which is our turnkey managed observability stack that is, again, based on open source tooling. The second thing is Deploy Now, which is a deployment-based stack that takes care of everything for your code from your Git commit right up to wherever it runs in your deployment orchestration tool. The third one is OpsVerse One, which is an customizable internal developer portal that uses Backstage as its base. And the fourth tool that we're working on right now is Aiden. And with Aiden, what we're trying to do is like leverage LLMs and generative AI to see how we can augment DevOps workflows, right? And for all the stacks that we have, we actually run them completely cloud agnostic. We can run them cross-region. And we also run them in this mode called private SaaS, which means that this entire stack, whether it's Observe Now, Deploy Now, One, or Aiden, can run entirely within your company's cluster, right? So in case you have data residency requirements or things like that, all of those kind of get managed from day one with the OpsVerse tools. So cool. Without much further ado, let's break down into what this topic is going to be about. So today, for the next 25-30 minutes, we'll talk about the cost of observability, and we'll actually talk about like what exactly you're paying for when you're talking about observability. Then we'll actually break down the spends, right? To say that, hey, when you say you're spending X amount of money on your observability platform, right? What exactly are you paying for? What can be migrated? What can be reduced, and so on and so forth. A bulk of the time we are going to be spending talking about cost optimization strategies, right? So we'll look at different facets of observability and see how you can make the wise choice when it comes to your observability spends. And finally, like Tero mentioned, we have like 5 to 10 minutes at the end, which we'll reserve for Q&A. So cool. Let's get into it. So the first thing first, right? Like why this topic at all, right? And the reason is very simple. I think over the last year or two, when we have like spoken to customers or probable customers or leads, usually the range has been very vast, right? We have spoken to some companies that have like 3 to 4 people within the team. They're like just starting off with their first product, launching it, just got their Series A or a seed fund. And on the other side, we have had companies that are like massive global conglomerates, right? But the common thing between all of these companies has been some variation of this question, like how do I calculate the ROI of my observability platform, right? Where basically they're saying we're spending X dollars per month on observability, on whatever they classify under observability. And they're trying to understand, like, is that the right amount of money? Do I need to spend more? Do I need to spend less? How do I right size my observability platform as a whole, right? And that is a very hard question to answer. We will look at this question again at the end of this talk and see whether we can come up with a good answer for how do I calculate the ROI of my platform, right? So now the question is obviously, why is it so hard to calculate ROI, right? And the first thing is like what we call the paradox of observability, where when things are going well, it's very easy to think that you're overpaying for your platform, right? Because even a system that goes down, let's say 20% of times, it means 80% of times everything is chugging along quite nicely, right? So it's very easy to think that 80% of times, why am I paying for this observability platform at all, right? But on the other hand, the moment something goes wrong, right, it becomes super, super critical for you to get as much data as possible so that you can identify the exact issue that is causing the issue within your team. And then also to reduce your MTTD and MTTR, right, which is your mean time to detect and your mean time to resolve. And in today's modern systems, right, especially when you bring in microservices, you bring in something like Kubernetes, bring in different orchestration platforms, you have like data pipelines that are running in the background, you have like different tools that are kind of talking to each other. It automatically becomes even harder because you're not really looking at one monolith where you have like one single workflow. That one application itself can have lots of different workflows that get hit. And if one of them goes wrong, then identifying that path that is causing issues again becomes really, really hard. And this is the other side of the paradox of observability, right? This is a common experience that we've seen with like a lot of companies that we've spoken to and we work with, where we've noticed that a lot of teams, when they spend time building out great observability platforms, right, or again, tailoring observability platforms that work for their use cases, then as a whole, these end up being the organizations that end up having better engineering practices, which in turn obviously leads to better products. And better products usually have lower outages. And if they have lower outages, because they're already always observing the system, they know how to write scale their applications as well, they know how to take care of things, which means again, the use of the observability platform starts to feel less over time, right? What that means is that initially you start to see a few quick wins, but over the years, you start feeling that, hey, like I'm not really looking at that dashboard as often as I did because I don't really have as many outages. So is that really something that I should be looking at, right? But I think that's where the paradox kind of plays in. As I mentioned in the previous slide as well, it's actually a cause rather than the opposing view, right, of observability. So let's actually break down what you pay for when you're paying for an observability platform, right? And usually we break it down into these two columns where you either choose to build your own observability platform or you're buying some sort of proprietary product, right? And I'll share a few anecdotes as well as we talk about these cases, right? So let's start off with the build aspect of it. So say you're trying to build your own observability platform, right? Primarily, the things that you're paying for are going to be four things, right? You'll be paying for storage, obviously. You'll be paying for the storage of your observability data. You have to store for your compute as well. That is a compute that is required in order to like query your observability data, or like do some sort of correlation, get some sort of insights, so on and so forth. You may end up paying for data transfer as well, which is like network ingress, network egress, stuff like that. And finally, which is again a very, very critical thing, is manpower, right? And manpower can actually be split into two parts again. Like the first is the cost of actually setting up your observability platform itself, right? Where we've seen usually people can take even up to like 4 to 6 months to have a fully working observability platform from scratch. But it's not just about those 4 to 6 months spent, right? Because once that is ready and your observability platform starts getting used, and if it's used well, then you are in for even more problems because you then have to have entire team of people that is just going to be taking care of your observability platform, right? So that manpower is something that's always ongoing. And an anecdote for this is like something that one of our customers today, who was not a customer earlier on, they reached out to us last year, and they basically had a very interesting use case, right? Where they had like spent a few months building out an observability platform. Everything seemed to be working for them. They were very happy with everything. And then during the last IPL, they actually ran an advertising campaign, right? And when they ran an advertising campaign, automatically what ended up happening was there was a lot of data, a lot of users started flocking to their system. And it not only started affecting the performance of their system, but because their observability platform itself was not built to scale, the platform started crashing itself, which means that your application is down and you don't even have access to the metrics that tell you why it's broken, right? So they came out to us with a very, very frantic kind of plea saying like, hey, can we move to observe now immediately because we need to handle that scale on day one, right? And this is like a very common kind of use case. Scale is a great problem to have as an engineering organization, as long as you're not the person who's like responsible for keeping things up and running, right? And obviously, then the other side that comes in with the build system is obviously keeping things up to date, making sure all security vulnerabilities are patched, bringing in like certain features that enterprises need, and so on and so forth. On the other side, if you go to proprietary products, right, there you're paying for, again, storage, compute, data transfer, which is a very common thing that you'll notice between both the build and the buy side. But then there are other things that you pay for as well with any proprietary tool, right? You will obviously be paying a SaaS premium, which is a premium that you're paying because it's completely managed, a managed service that you're paying for. In many cases, now we have seen like most proprietary tools will try to get you to sign up for a support package as well, which means you're paying a support premium as well. And the third thing, which is like very, very interesting, is also a vendor lock-in premium, right? And this again, it's something that like really amuses me personally quite a bit, because it's actually a very funny case where all of these proprietary tools, right, proprietary platforms, they make it very easy for you to like bring data into their system. But the moment you say I want to take data out of the system, they make it next to impossible, right? And that's always like a paradox that I not really understood. I guess it's a way for them to make money. And again, an anecdote for this is like last year, we spoke to one of our customers who was a prospective customer back then, and they came up to us and said, "Hey, we are spending 50% of our cloud cost on a certain cloud observability provider." I won't take names, but let's just call it like Information K9, right? And what that basically means is for every dollar that they were spending for their application, they were sending another dollar just to monitor that application, right? And that is an absolutely ridiculous place to be, because that's not what observability or monitoring is all about, right? You do really want to right size. And the problem again is like once you're tied into a vendor and you're locked into a vendor, it becomes really hard for you to move data out, because in many cases, a rip and replace is very, very hard to do, right? So now let's look at like why exactly you end up paying so much money, right? We spoke about storage, we spoke about compute, we spoke about network usage and like manpower and some of these things. But even today, what ends up happening is that most of your observability data is almost never accessed, right? Once it's in your platform, it's just lying there. Like I mentioned, for a system that's up 80% of time, you're just accessing data for the 20% of time that it's not going to be, that your system is not functioning most of the time, right? You're just waiting for an alert, you're waiting for something to go wrong, which is when you want to look at your observability data, which is an unfortunate place, but yeah, that's kind of where we are at. The second thing is like, which is very common, is that the data is not in a format where it provides any information, right? And this, I think, is like something that we all learned back in school and college as well, that there's a big difference between data and information, right? And unfortunately, today we see again a lot of vendors that talk about observability in general, where they talk about being able to handle big data, right? But data has no meaning unless you're able to actually generate insights from that data, right? Or like create something actionable from that data. And unfortunately, most of them shy away from talking about this at all, because that's not the business model that they're looking at, right? It's more data equals more money, so bring in as much data as you want. And the third thing is like most of the information or your observability data is siloed away, right? And this is very, very common when you have like a large organization, especially in the enterprise, right? Where different teams kind of use different tools, which means that team A is using a certain observability data tool, team B is using something else, team C is using something else, and they kind of sort of know where the data flows, how the data flows, but it's very hard for them to get a broader picture of like how data flows. And if team A gets like a 30% increase in API calls, right, how will I be impacted by it, right? It's very hard for them to answer even simple questions like that. But unfortunately, almost everyone ends up paying a good chunk of their cloud cost for observability, because they just assume that that's what everyone else anyway does, right? Everyone's doing it, so let me also do it. And that's why like this talk, this webinar is basically aligned to like show you some strategies that you can use to eliminate these cloud wastages that you're doing. So what can we do to be better, right? So we have like, I'm breaking this down into 5 or 6 different categories. So we'll talk about ingestion, we'll talk about infrastructure, we'll talk about the tools that use themselves, we'll talk about storage and storage optimization, and we'll talk about policies and other miscellaneous things that you can fix as well within your enterprise, right? So let's get started with ingestion, right? And this is something that is a personal gripe for me, and I know Arul and a few others at OpsVerse, where a lot of companies, right, they take great pride, like I mentioned, in saying that, hey, bring in as much data as you want and we handle all of it, right? But all of the data that you bring in for observability may not really be useful, right? So this is why when we talk about ingestion, the first thing that we recommend to nearly every person that we talk to is to look at sampling, right? Sampling is your best friend. You always need to like understand how exactly data needs to be sampled to be brought into your system. There's a lot of different use cases that we have where sampling can be really helpful. Sampling intervals at a simple level, right? If you're scraping your dev pods, for example, at a 15-second interval, increasing it to 30 seconds automatically reduces your metric usage by half, right? It basically reduces it by half. Same way for production as well. If you have like applications, not all applications are built alike. And unfortunately, today, most providers try to talk about systems like they're all built alike. But unfortunately, even today, I think most applications that we have within our system are more pets rather than cattle, right? So you actually need to figure out how often you need to sample, how likely things to fail, how actually you need to, what is the kind of data consistency that you need for each application, right? The second thing that I'll talk about is like head and tail sampling. Again, very, very interesting. Lots of people, like I mentioned, if a system is working fine 80, 90% of times, then you don't really need to sample all that data that's coming in that says just 200 okay, right? So this is where something like tail sampling comes in very useful, where you can take that decision on whether you want to sample some data based on whether it's an error or not, right? If it's an error, you want to bring it into your observability system because you want to then be able to understand where something broke within that API call or within that gRPC request. But at the same time, maybe if it's a 200 okay, you just want maybe 10% of those traces to be sampled, right? That is like a very, very simple way to like work on your sampling cost. The second thing is like using tired logging, right? Again, as engineers, I know I'm just as guilty of this as almost anyone else. Everything that I did was a log, right? I always had logs within my system. And then because it always helps in debugging, right? No matter how good tools get, there's a certain joy to having that console.log within your system or having a system.out.println within your Java application that tells you exactly what is happening, where you are in the code, what are the other variables that are there, and so on and so forth, right? But at the same time, logging and storing logs as raw data is quite expensive as well, right? So that's why we always recommend use tired logging. That means that separate out what you think is a debug log, what's an info log, what's a warning log, and identify what are the kind of logs that you actually want to bring into your observability platform, right? Maybe for your stage and for your production, by default, you just want your info and warning logs, right? You don't really want your debug logs. Maybe when something goes wrong, you want to turn on your debug logs and then bring that additional information in as well, right? Those are all calls that you need to take that help you with like identifying ingestion. The third thing is like using formats that are better suited for ingesting data. And this again, like I spoke in the previous thing, when you're talking about logs, for example, right? It's very easy to say, here's a file, there's a text file that has logs. Let's try to push it into our observability system, right? But purely from an ingestion standpoint, even something as simple as compressing it and converting it into a GZ file, right, saves a lot on the amount of money that you pay for ingesting your data, right? So most common formats that we recommend is either a GZ, that's very, very simple. Most tools support a GZ by default, or if you can afford it or have tools that support it, then use something like a protobuf, right? A protobuf is made for data transfer, it's made for data pipelines. So it actually compresses data really well and ensures that what you see in your observability platform is what you want to ingest, right? So this is a very quick anecdote again from a tweet that I saw a few days back, where someone spoke about like saving $27,000 a year by removing 10 lines of code, and they were all print statements. And one thing to quickly note is also that not just our print statements, when you bring it into your observability system, they're mostly wasted, right? Because no one's really looking at your debugging statements that people have introduced, that engineers have introduced. But at the same time, there's also a performance overhead, right? To having like all sort of print statements within your application. And especially if you're working in sort of a high performance environment, then stripping off your print statements actually helps in terms of your resource utilization and performance as well. So let's talk to the next thing. We'll talk about cardinality next. Now, cardinality is this massive beast that everyone talks about, but no one completely understands or no one seems to grasp it well enough. So maybe I'll spend a quick minute talking about what cardinality actually is, right? And in a very simple term, let's look at a Kubernetes cluster. And let's say that for every metric, you have 5 nodes and you have like maybe 3 applications, right? So that means that for every metric that I'm capturing, if I want to capture which node that metric has come from and which pod that metric or which application that metric has come from, then that means there is a total of 5 into 3 combinations, right, for that metric, which means that I'm going to have 15 combinations. That means that when I go to my time series database to store my cardinality for my metrics, I automatically need to store 15 different time series, right? I need to create 15 different time series and store them out there. But now let's say that I get rid of the node altogether, right? I say that I don't care about which node is actually running my workload. I just need to know what is the application, right? In that case, I automatically bring down my cardinality from 15 to 3 because there's only 3 applications, right? So every metric will either say A, B, or C. So this cardinality is something that like can blow up in your face very, very quickly. And it's a very, very common problem for most organizations that we've spoken to of like figuring out like what are the labels that they actually need, what is the cardinality that actually makes sense for them, right? A common use case we've seen is like in some cases, people using things like username for metrics, right? Pushing a username into your metrics, which kind of makes it very hard because it blows up cardinality very quickly. You want to have as low cardinality as possible for performance, right? So again, a common thing that we tell customers to do is understand from your use cases what are the namespaces that you're actually pulling in data from, right? If you have namespaces that you're not really looking at, then maybe you want to like drop those namespaces altogether. Similarly, metrics themselves, right? Maybe there's a lot of metrics that you're pulling in that you don't really need. Do you really want to store them? If you've never used them for the last, let's say 12, 16, 18 months, right? Do you really think you need the metrics at all? That's a call that you need to take. And same way, like I spoke about it, if there's metrics that don't really matter to you, labels that don't matter to you, it makes sense for you to drop them as well. Again, it's a very common misnomer that like observability means having a kitchen sink approach, which means take everything and like dump it into your observability platform. But that's not the case, right? And especially with metrics, when you're talking about metrics and you're talking about any sort of time series database, cardinality always becomes the biggest enemy when it comes to scaling, right? And the moment you have problem with scaling, you have issues with your cost as well, because you have to then throw money at a problem to be able to scale horizontally, vertically, however you want to do that, right? The second thing is like log analytics, right? This is again something that's very, very useful. Having log analytics instead of logs to metrics instead of long-term log storage, right? Again, for the same reason that I spoke about in the previous slide, most of the times, right, when you're looking at logs, you're not really looking at logs. You're trying to see how many times did a specific log come up in the last hour, right? Or you're trying to figure out, there's some number that's there in the log and you want that extracted out, right? So it makes sense for always use systems that can pull out that information from your logs and like store it as a metric rather than try to store the log itself, because both the log is harder to query in general and the log is, again, what I spoke about, it is data, but the metric that you're pulling out from the log will be information that you can then generate things on top of. The third thing we'll talk about is infrastructure. Infrastructure, again, pick machines based on your storage and query requirements. Now, again, this comes down a little bit to modern kind of architectures, especially in the DevOps side of things. We have started treating every workload like they are cattle rather than pets. But unfortunately, most observability systems have very, very different requirements in terms of like whether they are constrained by CPU, whether they're constrained by memory, whether they're constrained by something else. Maybe they make use of both, and so on and so forth. So it's very important when you're building your own observability platform to pick machines that make sense for your observability needs, right? In AWS, for example, depending on whether you pick a T machine or an M machine or a C machine, it does make a difference, right? It may seem like it's a small difference because most of them seem similar, but in our use case, we have seen a massive difference in terms of performance, which means that much fewer machines, if you're using a compute intensive workflow, then a C machine, you can use much fewer machines than an M machine, for example, right? Similarly, another thing that we suggest is like whenever possible, use Graviton. AWS offers Graviton out of the box. They're really performant machines. There is a performance differential with regular AMD 64 machine. But even if you account for, say, I need 5 machines with AMD, if I need 6 machines with Graviton for the performance differential, it can still work out cheaper for you, right? So especially for infrastructure, if you're working on infrastructure, very, very useful tip is like try to use Graviton as much as possible for whatever your workflows are, because even with the perf differential, it can work out cheaper. And finally, yeah, the third thing is like something that I think most people have been doing to some extent or the other, which is leverage spot instances and annual commits. Both of them together also make a great pair, right? So for example, if you know that you have very spiky observability needs, then try to leverage spot instances as much as possible along with like autoscale or something like that. And similarly, annual commits are always your best friend. The day when any customer comes up to us and tells us that, hey, I can predict how my observability needs are going to grow linearly, is the day that I can predict exactly how much you will have to spend on your observability cost, right? Because I think having some sort of annual commit really, really helps in terms of like right sizing your infrastructure for observability. So next we'll get to storage. Storage it's very commonly known, the speed is inversely proportional to the price. So that means that memory is more expensive than SSD, is more expensive than HDD, is more expensive than S3. And that also means that the performance goes in the opposite direction. So memory will be faster than SSD, than HDD, than S3. Uh, and that's why like it's quite important that if your tools support it, and we'll talk about it a little again in the next slide, try to use tired storage as much as possible, right? And what that means is that if your observability platform can support it, then use the latest data that you have, maybe the last week or the last month, which is most likely to be queried, right? Try to store it in an SSD. But for data that is a month old to say the next 3 months, right? Maybe you want to store it in HDD. From 3 months to maybe 12 months, maybe you want to push it into S3 instead. And from anything that's older than that, right? And usually we've seen like for, especially in fintech and health tech kind of domains, because they have like the reason they want the data stored is not because they need to query it, but it's more of a regulatory requirement. Then Glacier again offers a great way for you to store data, right? And as required, if you ever need to query data from Glacier, you can obviously unfreeze the data into S3 and then query it from there, right? So again, it makes a great sense to like use this kind of understand like what your use cases are, how your querying happens, and accordingly take data, right? And third thing is like identify your retention policy. And especially here, I mentioned that this is likely the most impactful decision that you'll make. The simple reason being like most customers that we have seen, they seem to think that logs, for example, right? Hey, I want 6 months of my logs because I'm going to query 6 months old data, right? But more often than not, we have seen if you just see the usage over the last year and a half, there's very little amount of data that they've queried that's more than 2 months or 3 months, right? Now, again, this can be like a two-sided sword in some ways. So if at any point of time you need your data, then it becomes like problematic for you because of your retention policy. But that's why like this retention policy does tie into your tired storage as well. So like if you have a retention policy that says that, hey, let me just keep the last 3 months data on this hard disk, and like let me take the older data and push it into some sort of object store that is cheaper to store in, right? That kind of gives you the best of both worlds in many ways, while also saving quite a bit in terms of your cost. But at the same time, yeah, one more thing that I'll quickly add is also S3 cleanups, right? Which I've seen a lot of customers not do, where they assume that S3 is cheap to store in, so let's just dump all our old data into S3. But very quickly, the price that you're paying for S3 also in many ways starts adding up over time, right? And this is now data that's not just 6, 12, 18 months old. It can be like 2 years, 3 years, 4 years old data that in many cases, customers don't even know that they're storing that data, but it's an S3 bucket that AWS is charging you for example. The thing next we'll talk about is tools, right? And this ties in a little to the previous things that we spoke about. This is like the very thing that's very important for us when we build out tool stacks as well, is like use tools that compress data well while allowing scaling, right? Now, what that means is that, for example, a very common thing we have seen, a very common complaint that we see is with the ALK stack, right? Very great stack, very nice to start off with. For the first few months, first few years, it scales beautifully as well. But the moment you hit any sort of scale, right, the ELK stack will start screeching to a halt, right? And then that's kind of the place where you'll end up like spending way more money on your ELK stack than you will for anything else that you do within your company, right? And again, babysitting ELK is its own problem, right? So on the other hand, like we have some tools that we use, for example, Loki, right? Loki stores data in S3, which again, coming to the previous thing, allows us much cheaper storage. It also allows things like indexing, which means that you can actually index data as well, which allows you faster querying for more recent data and slower querying for older data. But again, there's things that you can do to allow Loki to scale, right? Which is very interesting. The second thing, other example is like ClickHouse. ClickHouse for tracing. So we store our traces within ClickHouse today. And by default, Jaeger that we use internally uses Cassandra for storing traces, but we use ClickHouse for multiple reasons. One is ClickHouse is great at compressing data, right? It does a really good job of compressing data. But the second thing, which ties into the previous slide as well, is that ClickHouse allows you to do TTL-based retention, right? So you can say, for example, let me store the latest data that comes into ClickHouse into a certain table that's like very fast to access, right? But older data, I can actually push it into S3 and still query it via ClickHouse itself. So those things like make it very easy for us to actually scale very easily while not having to worry about changing our tools as we hit scale, right? The third thing, again, like from a tools perspective, is like certain tools now that we use internally allow you to downsample older data instead of deleting, right? Now, what this means is that for more recent data, maybe I want data to be stored at a 1 minute kind of interval or 30-second kind of interval because I really need that most recent data. But at the same time, for older data that I have that may be like 3 months, 4 months old, rather than deleting it, I can downsample instead. So maybe I'm going to sample that data at maybe a 1 minute or a 1 hour or a 1 week kind of duration. So I still have that historic context of like how certain metrics were performing while not deleting altogether that data. But at the same time, when I'm downsampling, it means that I save a lot on storing that metric itself, right? So that again is very useful. Downsampling older data, again, tools that kind of help you to do that are very useful. Networking, two quick things that we have here. One is VPC peering. Again, recently, I think every cloud provider has kind of understood that egress is something that they can charge for quite heavily. And a very common thing that we hear from customers is, hey, like everything else, all other costs seem under control, but I'm paying a lot for networking, right? Just for data, bringing it into my system and taking it out of my system. So VPC peering is always your friend for, especially with your observability platform. As much as possible, always try to set up VPC peering, which saves a lot on the cost. And the second thing is like avoid cross AZ or cross region access when possible. Now, what this means is that today, AWS, for example, it charges you money when if you have one application that's running in US East 1A and it tries to access a database in US East 1C, right? Then automatically you are paying for that the cross AZ data access as well. So as much as possible, exploit locality. Now, this is again a bit of a thumb rule. I don't think there's any way for you to like completely get rid of like cross AZ or cross region access, but as much as possible, always try to limit it. There are certain tools and strategies that you can use to do this, which we use internally as well, which kind of allow you to like run observability at a lower cost as a whole. But yeah, wherever possible, when you're building out your own observability platform, try to avoid cross AZ and identify where your cross AZ and cross region access is happening and try to exploit locality as much as possible. Final thing, yeah, like we have some miscellaneous things here. Consolidate your observability tooling. This basically means that, like I spoke about in the start, right? We have seen way too many customers or probable customers where they have 4 different tools that they're paying for, and still their teams don't really have insights into what's happening as a whole within their system. So it's very important to avoid this duplication of data, right? Because you have the same application that is sending data to 4 different places, and still everyone is going a little blind into what's happening, right? So it's super important for you to be able to consolidate your observability tooling and understand like where exactly your data is flowing, right? And something that helps with that is something that we've recently been experimenting with internally, as well as like we've seen more organizations do, is having observability data owners and team credits, right? Where what this means is that you have every team, for example, has a certain amount of credit on how much data they can send to the observability system, right? So let's say you say like, hey, you can send like 500 gigs of data to the observability system. And maybe at a very simple level, if we talk about just ingestion. Now, if you go above that 500 limit, then automatically what's going to happen is that the whoever owns the observability data within that team gets a notification saying, hey, your team credit was 500 GB, but you have spent say 550 or 600 GB. So you need to bring that under limit, right? It's very, very important that this observability cost is not something that is just borne by the DevOps team or like by someone in finance team who's looking at it and saying, hey, why are we paying a certain platform so much money? Why are we spending so much on observability, right? As much as possible, you want at both the org level and at the team level, people to have visibility. And at the same time, it should also be actionable, right? So in the example that I gave, if you say you're spending 550 GB on your observability from your team, right? That alone does not give me enough data, right? Where is that 500 GB being used? Was it being used? Was it being spent evenly across the month, or was there like a spike somewhere in the middle, right? Was there a release that coincided with maybe like some logs got added or some debug logs got added that kind of bumped up the amount of data that I ended up using, right? Was there some new metric that we started pulling in? Did we integrate something else? Did we integrate some third-party API within our system? That kind of visibility actually helps with the team being able to like do something actionable with that data. And the final thing, which is a very small thing relatively, but I'll still call it out, is today a lot of cloud providers do some sort of auto monitoring. With AWS, you have AWS CloudWatch. With GCP, you do cloud logging, cloud monitoring as well. In many cases, we have noticed that most customers, they're using some other third-party tool for their observability, but they still keep paying for CloudWatch and GCP cloud logging monitoring. And the reason is because now I think for most of these tools, they are enabled by default when you sign up, right? So again, a quick way to like save some money is like understand what the cloud provider's auto monitoring is provided, and then turn it off if you're not using it, right? If you're using it, great. If you aren't, then definitely look, that's again some place to look at when you're looking at pricing. So to capture all of this together, right? The most important thing probably the most important slide in this entire thing is like probably captured in this slide, where with the entire observability cost, right, we want to prevent a tragedy of commons in many ways, right? Now, what that means is that, as I mentioned at the very, very start of this presentation, right, we spoke about how do you calculate ROI, right? But ROI is hard to calculate because different people are calculating different things when they're looking at return, right? So, for example, your DevOps team is looking at something very different when they're looking at return on investment of their observability platform. The head of engineering is looking at something very different when he's talking about the same thing. He or she is talking about the same thing. And an engineer, she's talking about something else altogether, right? When she's talking about return on investment. So observability cost is not something that you should look at just from one lens, but there are like different facets that you need to look at it. And using like some of the tools that I spoke about in the previous slides, you will be able to like bring that ownership of observability cost into a shared sort of model where like different stakeholders have a say in how exactly spend on their observability, right? At the end of the day, there's no use if you're spending thousands of dollars on your observability platform, but your engineers at the end of the day are still struggling with like very, very simple kind of use cases that they want. And at the same time, the opposite also works true, right? If you have a system that you're spending almost no money on, but at the same time, your engineers still are not finding any value out of it, then that doesn't mean that you're saving money. It means you have like wasted that money as well, right? So it's very, very important for you to understand that observability cost is always going to be a shared conversation. And finally, I'll just end with this like one statement which probably encapsulates a lot of what we're talking about today, where we say premature optimization is the root of all evil, right? Which is something that Donald Knuth had famously said. And what this means is that in no way do I mean that you, as an organization, you need to look at this webinar and then go back and implement all of these things, right? All of these are actually trade-offs, right? So you need to identify within your team, within your organization, which of these trade-offs make sense for you, right? In some cases, it may not make sense for you, depending on what are the applications that are running, depending on the constraints under which your team is operating. Maybe Graviton doesn't work for you at all, right? Maybe you're using something else altogether. Maybe your cloud doesn't support an ARM architecture at all. There are like so many other ups and downs that are possible. So yeah, it's very important to understand that in no way is this like a complete prescriptive thing to say that you need to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and your observability cost will come down. But I hope that with just this talk, we kind of have a fair idea of like some of these things that we have learned as we have like built and scaled Observe now, right? And yeah, with that, I'll end the talk. A lot of these things that I spoke about in this webinar are things that we learned in some cases the easy way just because others had done these things before us and we kind of use the best practices to build these out. And in many cases, we learned these the hard way by building things out a certain way. Then the moment they've hit scale, it's either gone, it's burst out in terms of cost, in terms of optimization, or not scaled at all. And then we had to like redo and rework a lot of these things. So in case you're interested in like checking out some of these things that we worked on as we have built out Observe now, there's this QR code. You can scan that, and you'll get to learn a little bit more about OpsVerse, what we do, and yeah, definitely more about Observe now. And I hope this was useful for everyone. So I'll take it back over to Tero for Q&A.
Hey, thank you so much, Naveen. That was really an insightful session. I hope, everyone, got to learn a lot on how to optimize their observability costs. So we have a few questions out here. The first question is from Rajat. It's high data in production, how data processing lag will handle.
Can you repeat that?
High data in production, how data processing lag will handle.
Yeah. So I'm assuming that the question here is like, if you have like high data ingestion, then how exactly will the observability platform be able to manage that? Now, this is kind of a core engineering kind of question, right? Which again, this is one of the things that we learned the hard way, right? So for example, within our system, we use collectors, and initially we try to horizontally scale as much as possible. But again, with anything where you're hitting scale, horizontal scaling will always be your friend, right? And what that means is that as much as possible within that entire write workflow that you have or your read workflow that you have, you want to leverage as much distributed systems as possible, which is why like almost all the systems that we run as part of Observe now are built in the horizontal scaling mode because we want to allow that, right? Again, that's always a trade-off because how do you right size that is again a question. When you say big data, right? For some organizations, like a few GB, if they're using like a few MB every minute, then a few GB a minute is considered big data. But for if an organization is like used to a few GB, then maybe their definition of big data ends up being like 100 GB a minute, right? So again, it's something that right sizing still requires work. There's no one prescriptive thing, but usually what we have seen is like being able to right size your individual machines along with horizontally being able to scale systems, right? Is kind of the thumb rule for being able to scale as you grow your data. I hope that answered the question. Yeah.
Thank you so much, Naveen. I know we're right on top of time. We'll take a few more questions. If you have any questions, please feel free to drop in the Q&A. Naveen, you did mention earlier about the logs and metrics, right? Like logs, until and unless it's metrics, right? It's not useful. Can you elaborate on that one, please?
Okay, yeah. So logs to metrics, this again is something that I think we are all guilty of in some ways, especially in engineers, right? Where we try to put in timers, for example, right? Where we say that something started here and ended here. And we add like a timer into the log that says like, hey, it started at a certain time and ended at a certain time, and you're trying to see how fast a function runs, right? Or a method runs, or how fast a database runs, for example, right? And all of these, when you're looking at things like time, when you're looking at things that are quantifiable in many ways, right? They can always be pulled out rather than having it as a log, than having it as a metric. Now, unfortunately, what happens is that in a lot of cases, pulling it as a metric becomes hard. For Observe Now specifically, we have built out our own log analytics or log aggregation machine. It's a module that we have on top of Observe Now that allows you to run some of these aggregations easily. But yeah, in general, like the idea is to say that rather than have this entire log where you're going to say like application X started at so and so, blah blah blah, application X ended at so and so, you pull that out into a metric because that's much cheaper to store than storing a log in general.
But we will take one more question. The question is, you mentioned Loki with S3. We're considering Loki, but we hear Loki has performance issues as we scale. What are your thoughts?
Yeah, that's a great question, actually. Again, right, some of these questions that I spoke about, right, some of the things that I spoke about, they're all trade-offs in some ways. Loki by default, because it uses S3 rather than something like ELK or something that uses ClickHouse, for example, right, as a data store, its performance is definitely going to be slower, but how much slower is something that you can control in many ways, right? So for example, Loki allows great support for indexing, which means that you can actually have Memcached or Redis as your index in the background, which means for most queried queries, you can actually end up having very, very fast querying, right? And at the same time, that means that for older data, it's going to still end up taking a little bit more time because it has to go to S3, and that data retrieval is definitely going to take more time for you. But in most cases, it's possible for you to optimize based on your read and write requirements, right? Looking in general, again, because it scales very, very nicely when you're trying to scale it horizontally, and you can split things into chunks as well. So there's a lot of tweaking that you can do around Loki to actually scale horizontally. And at least in our case, I think we managed to like find a nice sweet spot for us personally, where Loki is able to get like results fast enough that it's not frustrating for engineers that are using it, right? Because that I completely understand the pain of like having a system where like querying something simple and then it takes 10 minutes to come back with a response. But with Loki, we've been able to like tweak it to an extent where most queries we're able to like actually get really, really good response times in general.
Thanks, Navin, for the answers. And thank you, everyone, for joining in. If you want to learn more about what we do about Observability platform, do scan the QR code. We have a mid-year offer running. So do scan the QR code and reach out to us. We would be more than happy to take you through tailored presentations and talk more in detail. Thank you so much. Thank you, everyone, for joining. Thank you.
Thanks so much.